There are no hidden water lines here, no deep wells, and no rainfall in sight. It hasn't rained for 4 days, yet look at this. Clean water is steadily dripping into the basin. It's been doing this all night, consistent and rhythmic, because that is exactly how the system is designed to work. This is high-quality drinking water harvested directly from the atmosphere overnight. The device producing it cost me a total of $12 to assemble. I'm not claiming this as some revolutionary breakthrough or a high-tech secret. It's actually the opposite. Engineers have understood these principles for over a century. Fog nets and dew harvesters have been utilized for decades in the coastal regions of Chile, the Atlas Mountains of Morocco, and the highlands of Ethiopia, places where the power grid doesn't reach and traditional wells have long since failed. The reason you've likely never heard of this is frustratingly simple. The system works too efficiently and costs far too little for anyone to turn it into a profitable commercial product. So, let me walk you through the build. You already know this physics works. You've witnessed it your entire life without connecting the dots. It's the condensation forming on a chilled glass or the morning dew clinging to the grass before the sun peaks. A common spiderweb performs the exact same task that a $3,000 industrial water generator attempts to solve with noisy compressors and electric fans. The air surrounding you right now, regardless of your location, is saturated with water, invisible and suspended, just waiting for a cold enough surface to let go of its grip. There is a physical threshold known as the dew point. When air makes contact with a surface at or below that temperature, the water vapor has no choice but to manifest. It condenses, transitions into a liquid state, and begins to flow. What you are constructing is essentially a large-scale interface for that physical exchange. You need a significant surface area, positioned to face the wind and tilted so that gravity pulls the droplets down into a collection point. No moving components, no electricity, and zero maintenance. You set it up at dusk, and it performs autonomously while you sleep. Here is the fact that stuns me every time I consider it. The Earth's atmosphere holds approximately 37 quadrillion gallons of fresh water at any given moment. That is a staggering volume, more than all the world's rivers combined, just floating there, and almost no one is capturing it. That is the core concept. Let's look at the parts list, and I want to be completely transparent. This is as basic as it gets. A 6 by 6 foot shade cloth or mesh, the kind available at any garden center for about $5. The tighter the weave, the better the performance. You're looking for something closer to a window screen than a loose net. The mesh does all the heavy lifting here, so don't settle for a low-quality weave. Next, you'll need 4 sections of 1-inch PVC pipe for the frame, which shouldn't cost more than $2, even less if you use scrap material. You likely have zip ties in a junk drawer already. A section of plastic gutter for the collection trough will run you $3 or $4 at any local hardware store. Finally, grab a few bricks or stones to prop the frame at the correct angle. That's between $10 and $14 total. If you have the ties and bricks on hand, you're looking at an $8 investment. No specialized tools are required beyond something to cut the PVC, and many hardware stores will even make those cuts for you for free if you ask. The frame comes together first. Connect the PVC into a rectangle roughly 4 feet high and 3 feet wide. You aren't building high-end furniture. It just needs to be rigid enough to hold its shape against the wind without buckling. Secure the corners with zip ties if you want to skip the cost of specialized fittings. It will hold up perfectly fine. Now, stretch the mesh over the frame, pulling it as tight as possible. You want zero sagging. Secure it with zip ties every 6 inches along every edge. Think of how a drumhead is tensioned. You want that same even pressure across the surface because sagging mesh leads to pooling water, and pooling water means slower runoff and lower yields. Here is the critical mistake beginners often make. They lay the frame flat on the ground. Do not do that. A flat orientation means the water stays on the surface and evaporates as soon as the sun rises, leaving you with nothing. You need a tilt between 15 and 30 degrees, similar to leaning a ladder against a wall at a shallow angle. In this configuration, every droplet that forms will naturally roll downhill, hit the bottom edge, and fall into the waiting trough below. Position the gutter section directly under that bottom krunka. If you want to run a small tube from the trough into a storage jug, go for it, but it's not strictly necessary to see results on night 1. Now, Let's talk about placement, which is more vital than most people realize. Orient the face of the mesh into the wind, not sideways or away from it. You want the air moving through the mesh, not around it. Walk around your property at twilight and feel which direction the breeze is coming from. That is where the front of your frame should point. Raise it off the ground slightly. Even a foot makes a measurable difference. Air near the surface is often drier and warmer than the air just a bit higher up. Also, keep it away from the spot where the morning sun hits first. You want the dew to accumulate through the entire night and remain in that trough when you come out to collect it, rather than burning off before you wake up. Set it up before sunset, return at dawn. That is the entire routine. What is happening overnight is simply physics doing what it has always done. As the temperature drops, the mesh surface cools along with it. When it crosses the dew point, the moisture is forced out of the air. It condenses, forms a droplet, finds another droplet nearby. They merge to gain mass, and gravity does the rest, rolling them into the trough. By morning, you've created something from nothing. During my first test run in average humidity and temperatures in the mid-50s, with no fog and no rain, I collected just over half a liter. That sounds modest until you realize those were completely ordinary conditions. There was nothing special about that night at all. In humid climates, coastal regions, or river valleys where morning fog is common, people are harvesting 1, 2, or even more liters from a setup this size in a single night. Scale the mesh up to 10 by 10 feet, and you are looking at serious daily water production from a system you built in a single Saturday afternoon with parts from one hardware store run. A family of 4 requires about 2 liters of drinking water per person per day. Scale this correctly in the right climate, and you are meeting that need entirely from the air. No bills, no infrastructure, and no need for anyone's permission. Now, let's address the safety of drinking it. Atmospheric water is actually remarkably clean to begin with. It hasn't touched the ground, nor has it run through soil or aging pipes, so it bypasses most of what makes surface water risky: bacteria, agricultural runoff, and heavy sediment. However, it can pick up fine particulates from the mesh over time or trace pollutants if you are in an urban or industrial area. The fix takes 5 minutes and costs about $3. Take a plastic bottle, cut the bottom off, and flip it so the neck points down. Layer materials inside from bottom to top. Cotton first, then activated charcoal, available at any aquarium store, then a layer of fine sand, and a final layer of cotton at the top. Pour your harvested water through the top and let it drip out the neck into a clean container. That is your filter. It handles the particulates, absorbs most chemical concerns, and adds maybe 1 minute to your morning. If you want to be 100% certain, boil it or add 1 drop of plain, unscented household bleach per liter, wait 30 minutes, and it is as clean as treated tap water, likely cleaner, depending on your local utility. Free water from the air, filtered in minutes for a one-time $12 cost. The thing about this project that stays with me is how ancient this idea actually is. Humanity has been doing versions of this for centuries. The Incas engineered stone structures specifically to condense water from mountain mists. Fog nets have been harvesting water in the Canary Islands for generations. There are Bronze Age wells in the Negev Desert that archaeologists now believe were actually dew collectors, structures built not to store water, but to generate it. Somewhere in the last century, as indoor plumbing became the standard and municipal water became the default, we stopped thinking about it. We stopped needing to. The tap worked, so the old wisdom just sat on a shelf and gathered dust. $12 in one afternoon, and that knowledge is back in your hands. I don't know what your specific situation is or why you're looking for this. Maybe you're focused on preparedness. Maybe you're already off-grid, and this fills a vital gap. Or maybe you just enjoy building things that actually serve a purpose. It doesn't matter. It works either way. Now you know how. Take care, and I'll see you in the next one.